surface. In continuation of the previous session where we discussed the pentagonal plane surface, I am going to discuss few more problems related to the pentagonal prism, where I am going to discuss something on pentagonal prism. It's problem number 23, where it is resting on one of its corners on HP, and the perpendicular bisector passing through this corner is inclined at some degrees to HP and some degrees to EP. Now we explain very clearly. Say this is, if it is VP and if it is HP, is given that a Pentagonal Lamina of 25 mm sides resting on one of its corners on HP. Clear? So this is where exactly this corner. Here this corner touches on HP, and if I try to rotate this corner, it is like this type. So very exactly, because I told very clearly in the previous session. So this HP we are tilting at an angle of 90 degree. So this corner comes here. So the same sketch which I wrote here very clearly like this. This is for exactly the same case. You know. So it is resting on one of its corner here on HP, such that the perpendicular bisector passing through this corner to this corner. So this edge or side is an opposite side. So perpendicular bisector, this one is exactly this is the case. So this is at 90 degree. Perpendicular bisector passing through this corner. This is what exact perpendicular bisector passing through this corner is inclined at 30 degrees to HP and 45 degrees to EP. Now I thought very clearly. So this is exactly the case of beta. Here, basically, in the previous session I discussed something related to the beta case. For beta case, where it is axis is inclined, meridian is inclined, diagonal is inclined, and perpendicular bisector passing through this corner. These are the four cases where you need to go for the beta case, and we need to solve the same problems irrespective of the lamina, whether it is pentagon or hexagon or triangle, whatever it will be the case. Clear? So this is the case of beta. I told very clearly, I will repeat again. Clear? No? It is resting on one of its corners on HP, and to this corner, this is the side which is opposite to this corner. So very exactly, if I draw a line, so this is the perpendicular bisector which bisects this corner, which equally bisects this corner, which is equal at 30 degrees to HP and 45 degrees to EP. It is, I told you in bracket I written, it is beta case. Now these two are the common steps which will be a preliminary case for any kind of numerical which deals with the pentagon. Now, as I told, this corner touches HP, and if I rotate this, clear, no, which will comes exactly like this here. Now this A is a corner which is touching on HP. If I rotate this, an angle of 90 degree which comes here. So this is what exactly, and you construct the regular pentagonal lamina as I explained in the previous case. Where exactly, clear, no? If draw a 25 mm line, so mark 108 degree with the same 25, just cut an arc, from here just cut an arc, So if you just join these three, you will get a pentagon. So this is 25, from here 25 as it is, from same 25, cut an arc with 108 degree, that's it. So this is what exactly the process in which where we are constructing the regular pentagonal lamina in both front view as well as the top view. If you project it, you will get the top view of it. So that is what I written in point number A, where construct a regular pentagonal lamina with point A resting on HP and complete both top view and front view as in position 1. Now when it comes to point P, tilt the top view from position 1, such that the corner A resting on XY line. So this is corner A should rest on XY line, and where exactly the other end C dash D dash should lies on 30 degree line. Now if you put a protract here, so mark 30 degree line, so draw unknown length, then from the compass just measure this length, just cut an arc on this 30 degree line. Clear? And transfer all the two lengths as I explained in the previous case. So A dash to B dash, A dash to B dash, A dash to C dash D dash, A dash to C dash D dash. And if you put an arrow mark which you are looking from this side and project these vertical lines and horizontal lines, you will get one more pentagonal lamina as explained in the earlier session, which will resemble position 2. So which deals with the point B. Now when it comes to C, So where it is very tricky, especially for the case of beta numericals, as I told, four cases are there for beta. One is axis is inclined, other one is meridian is inclined, third one is perpendicular to bisector which is passing through the column which is inclined, and the diagonal is inclined. These four cases which deals with the beta. Clear? Now in this case of beta, how to draw it? Where exactly is given 45 degrees to be. First draw a line of 45 degree which is inclined to XY line, which is just below this one, below XY line. There is a 45 degree line, extend this unknown length with X as the distance. Now that's what I wrote here. Draw a line inclined 45 degree straight line. Transfer the true lengths of X with this length, which will be equal to this one. From somewhere else on this 45 degree line, just you take preferably two box below this XY line. From there, just cut an arc on this 45 degree line. Now from there, draw a locus line which is parallel to XY line. Draw a locus line which is parallel to XY line, which is equal to the length of X. Now this, as I told, which will be like this, and if I tilt like this, its shadow will be very reduced one. So this pentagon will be of reduced in dimension compared to this original one. Clear? So now measure this Y from the same corner which touches A, just cut an arc on this locus line, where we draw this locus line with the length will be equal to X, and this will be the reduced length. So just cut an arc, then project this line till it touches A and project till it touches XY line. And where exactly, if you mark it, this will be beta. So generally, if this angle is 45 degree with respect to VP, then beta will be 55 degree. Plus or minus 1 degree may be acceptable. So this is what exactly beta is, 55 degree. Now how to proceed? So after marking this beta line of 50 degree, now keep your hand like this type here, which is exactly like this type, or better you keep it like this type, the same pentagon. Clear? Now with this A, now rotate this A in such a way that it should touch on beta line. Clear? Like this type. Now as I told in the previous case, this is a box method. Transfer the true lengths with the help of box method from this corner where it touches this one, and you should draw this reconstruction of the pentagon only on 55 degree line. That is what on beta line. So that is what I wrote here. So you should only on beta angle. Clear? To get beta angle, and this, after getting this beta angle, transfer this pentagon prism only on this beta angle, is on 55 degree line. And with the box method, we just construct this pentagon as usual, as I told in the previous cases. Clear? And mark all these points A, B, C, D, E, and project horizontal lines and vertical lines with projecting an arrow mark calculation. Now after this projection, just move upwards, horizontal lines and vertical lines, and you may get one more as it is depicted in 4th position. Clear? That's what I wrote here. Project horizontal and vertical lines to pentagon position as shown in position 4. So similarly, similar kind of a numerical with an assignment with 30 and 31. Thank you for watching this video.